Welcome to Lesson 3, Graph and Interpret Tax Rate Schedules. Our objectives are to write piecewise functions in y equals mx plus b form, and to graph these functions in an online graphing calculator. We'll use Desmos Online, and then we're going to interpret our graphs. Now the graph below represents Colorado. Remember that Colorado is a flat tax, so look at our graph. We have one linear line, we have a constant rate of change, the slope is the same. It's easy to interpret. Our x-axes will always represent our income, and our y-axes will always represent our income tax liability. If you are somebody who makes $40,000 a year, then it's easy to come to the graph, find the 40,000, look at where it intersects the line, and determine that you probably make about you probably will owe about $2,000 in tax. Let's go ahead and look at some piecewise functions, and we'll compare. In this example, this is the table for married filing joint for federal, and remember that this is a graduated rate. The rate gets bigger as your income increases. Now down here I have three piecewise functions for the first three intervals, but notice that our piecewise functions don't look familiar because these are in y equals mx plus b form. When we wrote them in the last lesson, we wrote them like this. So if we take this second interval, we say that we are going to pay $1,605, which is here, plus 15%, which is here, times the amount that's over $16,050. So our income minus $16,050. And this is how we arrived at our piecewise functions before. But now we're going to graph them. So we really want them to be in y equals mx plus b form. They're easier to graph. In order to put them in that form, we just need to distribute to get rid of the parentheses, and then we'll combine like terms. If we distribute, then we would take 0.15 times our x, then we would take 0.15 times negative 1650. If we put that in our calculator, we get 2407.50. Our final step would then be to combine our like terms, the 1605 and the negative 2407.50. So if we do that, we're left with 0.15x minus 802.50. And that's the equation that we have here. So you can see then that we have the exact same equation. In this last interval here, we would do the same thing. We would just distribute the 0.25 into the parentheses in order to get our equation into the y equals mx plus b form. And when we do that, we end up with 0.25x and negative 16,275. So combining our like terms, we end up with 0.25x minus 7312.50. And again, you can see that equation here as well. Now that we know how to write our piecewise functions in y equals mx plus b form, we're ready to graph. When we graph these functions in Desmos, we'll just be entering in these three equations separately. The tricky part is that we have to let the calculator know that we only want to graph this function between 0 and 16,050. We only want to graph this function between 16,050 and 65,100, and so on. So for you, learning how to put in these domains will be very important. Here's a screenshot from DesmosCalculator.com. So you'll notice here's our equations. We have 0.10x, this is our first equation, and then we have y equals 0.15x minus 802.5, and then our final equation. So we've entered all three of these equations as y equals. Then you'll notice that we have something back here, and these are our domain restrictions. So you can see the type of bracket, the curly bracket, that is required in order to tell the calculator that you want to restrict the domain. Let's go ahead and actually go to the calculator so we can look at these more closely. When I put in this first function, this is saying we want x to be greater than 0. We also want x to be less than or equal to 1650. So if you remember the interval, it went from 0 to 1650. So this is the way you'll have to input it. Now look what it did to my function. It started it at 0, and it went all the way up to 1650. Down here, my x-axis represents my income, remember. Now let's look at our second function. Here, we are saying that we want x to be greater than 1650, but less than 65,100. So if we graph that one, you can see then that the slope gets a little bit steeper, and then it ends here at the 65,100. Now let's look at our third piecewise portion of our function. We have, this is our equation, and then we start at the 65,1, so we should connect right here to the end, but then we end at the 13,1450. So let's see what that looks like. Graphing that, that's this orange line. Look at how much steeper that is. So now you can make predictions about the rest of the intervals. What do you think those would look like if we graphed all of the intervals in that federal tax schedule? If we compare it to Colorado, which is down here, you can see the difference between how the federal tax taxes you and compared to the state tax of Colorado. Looking at these side by side, it's easy then to figure out how much tax you're going to owe for federal versus state based on how much you might make. So if we went back to that $40,000 amount here, you can see that for Colorado, as we said, we would owe $2,000, but for federal, we would owe over $5,000, maybe $5,200. Graphing is a good way to visualize how the graduated tax structure works, and it's a good way to compare different taxes. Going back to our lesson, let's notice where the line changes slope. These circled places are where the line changes slope, and those are called the cusps. And if you'll look at our domain, these cusps are the end numbers of our domain. So that can help you identify where the line changes. Another thing I wanted to point out, we were able to see our graph when we were in that Desmos calculator. If I go back to what that looked like, notice my scale. Notice how large my scale is here and down here. We would not be able to see any of these lines if we didn't go into the calculator and change the scale. Just in case you're not sure how to do that, go to this wrench here. Now some people just use plus and minus, but that's not always very effective. So if you go into this wrench, you can adjust the window manually. So typically you want your x minimum to be 0. I have it to be a little bit bigger just so we can see to the left just a tiny bit. But then your x maximum has to be the income that you think you're going to be analyzing at some point. So I have it going all the way up to $142,670. If I only had 10 here, would $10 of income make sense? And that would be no. So you want to make sure to make your x max big enough to look at all the income values that you're interested in. Same thing for y. So again, you can make y minimum be 0 because we wouldn't have a negative tax, but I like to look a little bit below just to give me some perspective. My y maximum, however, has to be big enough to show me all the different taxes that I may have to owe on the income that I pick. So my y max goes up to $21,020. So you will probably need to come in here and adjust this on your own. If you don't, you won't see very much of your graphs otherwise. All right, let's finish off by doing one interpretation. Let's figure out how much tax we will owe if we have taxable income of $50,000. Let's do it the old way, where we plug it into our equation, and then let's look on the graph and see how close we were. Well, 50,000 would fall into this middle category because our range goes from 16,000 to 65,000. So we would use this equation, which, by the way, is going to be easier for us to calculate the tax from when it's in the y equals mx plus b form. There's a little bit less to do since we've already simplified this. Okay, so I plugged in my 50,000. All that's left is I just need to simplify. So I'll take 0.15, multiply that by 50,000, and get 7,500. And then I'm going to subtract 802.5 from that, and I'll get a tax of approximately 6697.50. So let's see how close we can get that on our graph. Okay, remember that we said we have an income of 50,000, so that's right down here. If I were to follow that up, I can kind of see approximately probably a 6697, but if I want to know that number exactly, here's a trick you can do. What I can do is I can graph my income and see where it hits my line. Well, income, remember, is on the x-axis, so we would then type x equals. It's very important that you type x equals, or it won't graph it in the right place. So now I've graphed x equals 50,000, and it's put in this green line. If I come here to the intersection and I click and I hold down, I can then see, hey, for an income of 50,000, I'm going to have a tax of $66.98, which is what we calculated manually. This also helps me for Colorado. If I have an income of 50,000, I'm going to have a tax of $2,300. So the nice thing about graphs is that once you have graphed your equation, it's very easy to take your graph and find intersection points to determine how much tax you owe and interpret your equations. This concludes our lesson on graphing and interpreting tax rate schedules. So at this point, you should be able to write piecewise functions in the form y equals mx plus b, graph them in the online calculator, including graphing the domains, and then interpret the graphs and potentially writing new equations in order to find intersection points to determine precisely how much tax you might owe.